Section 3.8 is on page 309, talks about implicit differentiation. So suppose we want to find a derivative of the following functions. dy dx, here it will be 5x to the fourth plus 2. Hopefully that's straightforward. Of this function, dy dx, derivative of sinus cosine of x plus 0. You could write plus 0 if you wish. And here dy dx, we agreed we were going to memorize the derivative of a square root is 1 over twice square root of x plus 1. So we hopefully know how to do this. The left side, we've been kind of like just taking it for granted that, if y equals, then that's easy. The left will be dy dx without giving it much thought. But what if, and since we're dealing with powers, since we've been dealing with functions of x, y being a function of x, which means you always have y equal. It's been simple. The left side, you just write either y prime or dy dx. Now, what if you're not dealing with a function? What if you're dealing with a hyperbola, an ellipse, a circle, a sideway parabola, non-functions? Well, writing dy dx is not an option anymore because it's not y equal. It's not y on one side, everything else on the other side. If I say take a derivative of this with respect to x, well, the right side I'm used to. Anything with an x I know how to do. Derivative of x squared is 2x. Derivative of 1 is 0. That's easy. But the left side, we have a problem now. And the reason we have a problem, we don't know whether y is x to the fifth plus 2x, or it's sine of x plus 3, or it is square root of x plus x. If y was a, then this would have said x to the fifth plus 2x squared equal x squared plus 1. If it was b, then that would have said sine of x plus 3 squared equals x squared plus 1. And if it was c, that would have said square root of x plus x squared equals x squared plus 1. Now you'll notice the right side, when you take a derivative, is always 2x. That's not an issue. It's the left side. If it's case of part A, then don't you bring the power down, subtract 1 from the power, times the derivative of the inside? If it was B, don't you bring the power down, subtract 1 from the power, times the derivative of the inside? And if it was C, don't you bring the power down, subtract 1 from the power, times the derivative of the inside? So either way, when you see a power function, the outsidemost function is a square. What you do, you bring the power down, subtract 1 from the power, times the derivative of the inside. Since you're not sure whether it is A, B, or C, you'll say, you know what? Whenever you tell me what it is, I have to take a derivative of that by the chain rule. And that's how it works. Now, there is another way of doing this, but that's how we're going to do it. Let's apply it on the first problem really quick. And here we are. Find the derivative. So we just did one of those. Again, derivative with respect to x, if we take d dx, well, I know how to take a derivative of x squared, that's 2x. I know how to take a derivative of 4, that's 0. This is the problem. I see a y, I'll take a minus. Since there is a power, I bring the power down, subtract 1 from the power. Since I don't know what y is, again, each one of these y's in every problem I'm going to do could be either x to the fifth plus 2x, could be sine of x plus 3, could be radical x plus x. Since I don't know what that is, whenever you decide to tell me what that is, I'm going to take a derivative of that with respect to x. And now I'm going to solve for dy dx. So you're going to move this to the right hand side. Negative 2y dy dx is going to equal negative 2x. And if you divide both sides by negative 2y, and you'll get dy dx to equal x over y. Not traditionally what we get, but then again, this is not a traditional problem. Now, when I want to take a derivative of this with respect to x, okay, well, the equal I'm going to write right there. Derivative of the right side, well, that's just dy dx. We don't know what y is. Whenever you tell me, I'll take a derivative of it. Derivative of a constant is 0. Do you see that those two are multiplied? So again, whether y was like part a, x to the fifth plus 2x. So if the problem would have said x squared into x to the fifth plus 2x, or if it was x squared times sine of x plus 3, well, we'll have to use the product rule regardless. And the product rule, I know how to take a derivative of anything with an x. Derivative of x squared, I know that's 2x times y plus x squared, and the derivative of y is dy dx. And that's basically it. And I need to solve for dy dx, so we move all the dy dx's on one side, everything else on the other side. And we factor dy dx out of both of those. So reverse the distributive property. And if I want dy dx, I just have to divide by that parentheses and I'm done. And again, the answers don't look like a traditional derivative because there might be a y in them. That's normal. All right. And this problem, the same deal. I want to take a derivative of this with respect to x. Well, here we have negative, I ignore, use parentheses, the product rule. Derivative of x, I know that's 1 times y, plus first times derivative of y is always dy dx. Derivative of negative 2 is a 0. I'm writing that down just for your notes. And derivative of x over 7 is 1 over 7. And if I distribute the negative n, so negative x dy dx will equal 1 over 7 plus y, and dy dx will be 1 over 7 plus y multiplied by negative 1 over x. You could clean that up and get it a common denominator if you wish. You could say that is 7. That's 1 plus 7y times negative 1 over x. Or you could even say that's negative 1 plus 7y divided by 7x. To me, they're all the same. It doesn't matter. Now I'm going to show you another way of doing this if you like. A student showed me this trick and it seems to work really well. A student back in the days showed me that since students have a hard time with this, she said, okay, look, if you'd like, you could take just a derivative without stating with respect to what. So you treat everything like an unknown variable. X, Y, Z, it doesn't matter. You see a power function, bring the power down, subtract 1 from the power, times the derivative of the inside every time. Minus, you see a power function, bring the power down, subtract 1 from the power, dy, and the derivative of constant is 0. And then when you're done, look at the original problem and see that they want to divide by dx. Divide each of those by dx in this case. And dx over dx cancels out. And this becomes dy dx. And that's this step. We could do that if you wish. Again, a student showed me that and students seem to like that. And I'm going to apply that on the next, maybe on number 308. Let's do that first. So 308, I want to take a derivative. One way of doing it, I suggest, is for you, look, there's a power function. Bring the power down, subtract 1 from the power, times the derivative of the inside. Derivative of the inside, I have two things multiplied. Derivative of the first times the second plus the first times derivative of the second. Derivative of 3x, I know that's a 3. Derivative of y squared, right? Again, think of example A, B, or C. You bring the power down, subtract 1 from the power, times the derivative of the inside, which is dy dx. And now, distribute that in 2xy squared plus 2x dy dx equals plus 3 equals 2y dy dx. Move all the dy's dx to one side, everything else on the other side. Factor dy dx, and you end up doing that most of the time. And just divide by that parentheses and you're done. There it is. Now, you could, if you want, where am I going to fit that? Let me fit that here. You could also say, you know what, let's take a derivative of this. You could say, bring the power down, subtract 1 from the power, times derivative of x is dx times the second plus the first times derivative of the second. 3 derivative of x is dx. Bring the power down, subtract 1 from the power dy, and then distribute that in. And then divide everything by dx. And that's pretty much another way. Those cancel out, and you will be left with literally that step. Oh, that's a 2, not a 3. I get excited. There. All right. So you could do that too if you wish. Oh, I messed up here. That's 2xy, so that's 2x squared when you multiply xy times this and xy. Oh boy. So you move that, that's 2x squared, 2x squared, 2x. I gotta be careful with these things. All right. And how about this problem? Same deal. If I want to take the derivative, well, product rule. Derivative of the first times the second plus the first derivative of y is dy dx minus now here derivative of cosine is negative the sine of xy by the chain rule times the derivative of the inside, and that is, we just did the product rule, derivative of the first times the second plus the first times derivative of the second. And of course the right side, derivative of a constant is 0. And now cleaning it up requires a bit of algebra. That becomes a plus, distribute that in. Move anything that doesn't have a dy dx to the other side. So move that to the other side and that to the other side. That's negative y minus y sine of xy. And if I factor dy dx out of both of those, And if I divide both sides by the parentheses, pretty much I'm done. And that's where the bulk of the problem is. You know, all of this is algebra, simple algebra too. Now, let me give myself a bit of space. I should have done that from the beginning. dy dx, I could factor a negative y out of the top. That'll be 1 plus the sine of xy. And I could factor an x out at the bottom. That'll be 1 plus sine of xy. And I notice that those cancel out, and I'm left with simply negative y over x. Sometimes they cancel out, sometimes they don't. You should simplify all the way. And here, there's no way other than you solving for all of this. So the steps here are identical. Even if I say do not simplify, you have to do that much. Now, find an equation of the tangent line to the given graph. Okay, use a computer calculator and read a new software in this class, so don't worry about the second part. But the first part, find an equation of the tangent line. I need to find the slope of the line. The slope of the line, well, I notice this is not a function. So what do? I say, okay, well, let's take a derivative. So if I want to do this the long way, I'll say the product rule. Derivative of the first, bring the power down, subtract 1 from the power dx times y, plus x to the fourth, derivative of y is dy, minus derivative of x is dx times y cubed, plus x times derivative of y cubed, bring the power down, subtract 1 from the power dy, equal to 0. Divide everything by dx, and you're set. So again, this is not needed. I'm going to work this problem out without doing what I just did. Or you could jump from this to this straight, and let's see it. If I want to take a derivative of the product rule, derivative of the first is 4x cubed times the second plus the first derivative of y is dy dx, minus product rule. Derivative of the first is a 1 times y cubed plus x. Derivative of y cubed, again, think of the very beginning examples. That could be a function. We're not sure what that is. Bring the power down, subtract 1 from the power, times the derivative of whatever the inside is. And that pretty much puts you at this stage. So either way, you need to get that far. Now, we have a value for x and y. X is negative 1, y is negative 1, so that's 4 times negative 1 cubed is negative 1, y is negative 1, plus x to the fourth. Negative 1 to the fourth is 1, so you need to write it, dy dx, minus a negative 1, negative 1, this is going to be positive 1, so that's negative 3 dy dx equals 0. So what is the slope of the line? 4 plus dy dx plus 1 plus 3 dy dx equal 0. Let me give a bit. I thought I had enough space. And now I have 4 dy dx plus 5 equals 0. So dy dx is actually negative 5 fourths. And the equation of the line would be, remember the point is 1, 1, negative 1, negative 1. So the equation would be y minus y1 equal m into x minus x1. There it is, done. And we have another one like that. Let's do that as well. Again, if I want to take a derivative of tangent, that's secant squared of xy times the chain rule. Derivative of two functions multiplied, derivative of the first times the second plus the first derivative of the second is y prime equals derivative of y is y prime. There. Evaluated x equal pi over 4 times 1, that's pi over 4, times 1 plus x is pi over 4 y prime equal y prime. Secant of pi, if this is 45 degrees, 1, 1 radical 2. Secant is the hypotenuse over the adjacent. When you square it, you get a 2. So 2 plus pi over 2y prime equal y prime. That doesn't look like a prime anymore. Of course, y prime is dy dx. So 2 equal y prime minus pi over 2y prime. And if you factor y prime out, 1 minus pi over 2. So y prime is 2 divided by 1 minus pi over 2. And this is a complex fraction. We'll be dealing with this from the beginning of the course. LCD for the top and the bottom combined is a 2. And if they all have it, you just ignore it. And y prime will be 2 times 2, 4 over 2 minus pi. And the equation for my line would become, the point is pi over 4, 1, y minus y1 equal m into x minus x1. And there's my equation, and we're done with that problem. And now there's one more. Again, these are graphs of these functions, something we didn't deal with before unless you took parametric equation. The graph of the volume of the cards where the equation is given in the following. There's the graph. Find the equation of the tangent line. Graph the tangent line along with the form. Okay, again, you could do a line, that's not a problem. There's the equation. There's that point. We need the slope of the tangent. Slope of the tangent would be, take a derivative of this. Well, that's derivative of 2x cubed, bring the power down, subtract 1 from the power. Derivative of y cubed, bring the power down, subtract 1 from the power, times dy dx, because again, I don't know what that is, minus 9, I'm going to leave out, product rule. Derivative of the first times the second plus the first times derivative of the second. And of course, the right is 0. If I substitute 2 for x, 6 times 2 squared is 4. 1 for y, that's 6 times 1 squared, which is 1. Minus 9 into y, which is 1, plus 2 dy dx. So I have 24 plus 6y prime minus 9 minus 18y prime equal to 0. I'm looking at 15 minus 12y prime equal to 0. That means I'm looking at y prime equaling 15 over 12, which is 5 divided by 3, 5/4. And the equation would be y minus 1 equal 5/4 into x minus 2. Now I could solve for it if I want. I could say 5y minus 4y minus 4 equal 5x minus 10. 4y equals 5x minus 6, and y is 5x over 4 minus 3/2. So I could start at negative 1.5 and rise 1.25, 5/4 the slope, 1.25 and run 1. And if I draw a tangent line, again, if my scale was perfect, then guess what? There it is. It touches at the point 2, 1 as they state. That is the tangent. Now, what's a normal line? Find And what's a normal line? Well, the definition of a normal line, it's not defined in the book as a theorem. A normal line is perpendicular to tangent line. And what do you know about perpendicular lines? The slopes are negative reciprocals. So if the slope of this line is 5/4, the slope of the normal line is the negative reciprocal. And the equation would be y minus y1 equal m into x minus x1. Again, that's the answer. If you want to graph it, 5y minus 5 equal negative 4x plus 8. 5y equals negative 4x plus 13. And y would equal negative 4/5 x plus 13/5. And if you really wanted to use mixed numbers, now is a good time. That is 2 and 3/5. So that's about 2.6. So if I start at 2.6, about right there, and rise, negative 4/5 is negative 0.8. Go down negative 0.8, less than 1, and 1. Connect that with a straight edge. If my scale was perfect, again, I'm doing everything accordingly, go down and 1, those will be perpendicular. And that's pretty much what this section is all about.